You know how sometimes you stumble upon an argument online and it just spirals completely out of control? Well, it turns out that even the simplest physics questions can spark the most intense debates. Today, we're diving headfirst into one of those arguments to unpack a force that shapes our entire planet, yet some people will tell you doesn't even exist.
So, let's just jump right into the chaos, shall we? We're starting with a Reddit thread that was supposed to be about the Coriolis effect and centrifugal force. It all kicks off with what seems like a simple correction, but as you're about to see, it gets complicated really fast. Okay, so here's the opening shot. A user, Tiller42, makes this really bold claim. Centrifugal force is totally wrong. Doesn't exist. The real term, they say, is centripetal force. Seems pretty cut and dry, right? Case closed.
But hold on. Immediately, another user jumps in with a way more complex take. They're arguing that it does exist, but it's a reaction force connected to the Lagrangian of a particle? Whoa. Suddenly, a simple correction has blown up into a super high-level physics debate.
And, just to stir the pot a little more, a third person chimes in, saying it's not a reaction, it's just an illusion. So what is it? Is it fake? Is it a real complex force? Or is it just something we're imagining?
This brings us to the million-dollar question for this whole explainer. In this battle of physics and words, who's actually correct? Well, to find the answer, we have to step away from the keyboard and head out to a playground. To wrap our heads around a force that can steer an entire planet's weather, we need to start small. And honestly, there is no better example than a classic spinning merry-go-round. Okay, so picture this. You're on the ride, it's spinning around. Your friend is right across from you. You decide to roll a ball directly to them in a perfectly straight line. Seems simple enough, but what actually happens to the ball's path? And this is where things get really weird, because the answer totally depends on your point of view. For somebody just watching from the grass, the ball travels in a perfectly straight line, exactly like you rolled it. But for you, on that spinning ride, the ball seems to mysteriously curve away, like some invisible force is pushing it sideways. What is going on? Well, that invisible push is what physicists call a fictitious force. It's not a real force in the way that gravity is a real force. It's an effect that you only observe because you're in what's called a rotating frame of reference. It feels completely 100% real to you on the ride, but it's actually an illusion created by the spin. Okay, so now let's scale this whole idea up, because that exact same illusion from the merry-go-round is happening on a planetary scale every single second right beneath our feet. Our planet is essentially a giant spinning sphere. But, and this is the crucial part, not every part of it spins at the same speed. The ground at the equator has to travel a much bigger circle in 24 hours than the ground near the poles, which means it has to be moving a lot faster.
How much faster? Get ready for this. The surface of the Earth at the equator is blazing along at about 1,600 kilometers per hour. Meanwhile, at the poles, the speed is basically zero. This huge difference in speed is the key to everything.
So here's how it all connects. When something, let's say a missile or just a large mass of air, starts moving over a long distance, the Earth is literally rotating out from under it. Because the ground is moving at a different speed from where the object started, its path doesn't actually bend, it just looks like it does from our perspective. And that, my friends, is the Coriolis effect. It's that apparent deflection of any moving object on a rotating body. In the northern hemisphere, things appear to bend to the right, and in the southern hemisphere, they appear to bend to the left. So, okay, it's a pretty neat physics concept, but does this fictitious force actually matter in the real world? The answer is a huge, resounding yes. This illusionary effect has some of the most powerful and tangible consequences on our planet. Just take a look at this map of global winds. Without the Coriolis effect, wind would just flow in a boring, straight line from high-pressure to low-pressure areas. But instead, it bends, creating these massive, swirling weather systems, and the consistent wind patterns, like the trade winds, that have shaped global travel and climate for thousands of years. The impact is absolutely enormous. The Coriolis effect steers our global winds. It shapes the great ocean currents that regulate the entire Earth's temperature, and it's what gives massive storms their spin. It's the reason hurricanes rotate counterclockwise in the north and cyclones spin clockwise in the south. Not bad for an illusion, huh? Which brings us all the way back to where we started, that internet argument. Now that we're armed with our understanding of reference frames and these so-called fictitious forces,
let's deliver the final verdict.
So here's the final breakdown. From an outside, stationary point of view, the only truly real force is centripetal force. That's the inward pull that's keeping an object moving in a circle. But when you are the object on the ride, you feel an apparent outward push. That feeling, that is what we call centrifugal force. So ultimately, centrifugal force isn't some fundamental force of nature. It's the experience of your own inertia, your body trying to go in a straight line while something forces it into a curve. So in the end, the Reddit users were all kind of touching on a piece of the truth. Is it fake, a reaction, an illusion? It really all just depends on your perspective.
It just goes to show you that sometimes an illusion can be powerful enough to shape an entire world. It really makes you wonder, what other invisible rules and unseen forces are quietly orchestrating the reality we experience every single day?